So I'm here on Mr. Chippy's bench. It's Sunday morning and bizarrely I've got no church service up to have this afternoon. So trying to pull in a few things which are left over. This came in months ago. This is Maxon PM150 which the customer does wants putting on 4 meters. So although we do these business radios and we don't actually do amateur radio, I suppose this is the two together. We don't do amateur radio for customers, should I say. We will do these when we can fit them in, and this is the time. Somebody's also sent in a Motorola radio which they haven't had anybody on, and so they're wondering if it doesn't work. So if we've got to test something on 4 meters, well, we may as well do 2 at the same time. So these are available in 4 different bands, and this is where the problem lies. I think 2 of them will work okay on 4 meters and 2 of them will be pretty deaf. And you can change a lot of capacitors in the receiver, but I certainly don't want to bother doing that. So this is the NLA version, so theoretically if it's the right bottom it should be the right version. So we've got the number there, SMX 4050 NLA. So 4050 tells us it's VHF low band, the N tells us it's 12.5 kHz spacing, and then LA is the low band A band as far as I remember. It's all in the service manual, and the service manual was available for £100 and we bought one. Good, so he's got all the bits and pieces. So not only are there 4 versions of these, and you've got to appreciate when you program these, you've then got to put them on a signal generator or a test set or whatever. You've got to tune them. They don't just work. They're not like these cheap Chinese radios where there's nothing to tune inside. These have got to be manually tuned in a conventional way. So when I did the training course, I said, which screwdriver do you use to open them? This is the biggest one Wool will sell. So we're going to take the top lid off at this stage. There's a slot there, and if you can kind of get the screwdriver in there and force it off. So we've got the standard version here. So the standard version is this. The processor, there's 2 different types of processor. One for systems, which doesn't give you the ability to monitor, and one which is a standard one, and until it powers up I really have no idea which one this is going to be. So if it gives us monitor facilities, or we can program monitor facilities, it's, shall we say, the normal processor, otherwise it's the one for repeaters. Sometimes you get a radio with a subboard, so this is 16 channel maximum. You have to appreciate, if you have a taxi outfit and you're using business radios, the government give you 1 channel for every 100 vehicles. So if you have 120 vehicles, they'll give you 2 channels. So the number of people who actually want 16 channels is so few and far between that it just makes them easier to work than not having blooming great big displays and things. So most of our business customers will have 1 channel. So 16 channels is the standard version, and then there's one with a board that sits on the top, which is called the systems version, that has cell call as well as more channels. And one version has 32 channels and the other version has 99 channels. I don't think I've seen the 32 channel one, I've only ever seen the 99 channel one. We're talking about the UK. These radios are different in different countries, especially in America, where the GE monogram was obviously made by the same people, but is a different radio. So in other markets, the radio can be programmed through this, not in the UK. Forget that. The EEPROM removes. So I'll take the EEPROM out. Oh look, I've got I've got fingers that don't do it. Well, I've never not been able to pull one of those out with my fingers. What is wrong with me today? How am I going to play the organ later if I can't pull the EEPROM out of this radio? Oh well, we'll put a little bit of pressure between it and the socket with a screwdriver and not bend the pins and carefully get it out. Pin 1, of course, to the right, it's notched and it's notched on the board. So we take the chip out, we put the radio to one side. Now we have to get SMP 4001. We also could use SMP 4000 programmer. It's all done in hex. It is a pain in the bottom, so we use SMP 4001. So I'm going to pause the camera and we'll get that out. You're going to take SMP 4001 box apart because the sockets come away from the lid in our Go box. So I've never looked inside one because I never have needed to. So now you know what's inside. Have we got some glasses that would enable me to actually see? I'm not at my bench, I'm at Mr. Chippy's bench. So what's this? 80C31BH with its reference crystal 7805 and a custom chip here, which I'm not taking the label off, which of course says SMP 4001 in there. And then we've got some kind of interface thing, which is a 74LS 373. 74LS 373N. So not something easy to replicate. It's a custom double-sided board. We just need to put some glue on there, if there's any on this bench. I don't, you normally would use only Bostik, but we seem to have got an alternative on this bench. Must have had some pressure on it in transit. These do come up on eBay, but expect to pay 100 quid. We'll get the ZIF socket back in position. And hope it's going to stay put. So I'll put the screws back in and then we'll connect it to my Toshiba T1910 laptop. I've never seen these work through DOS boxes and DROS boxes through Windows. There was a list of computers at the time and they actually used a Hyundai, South Korean firm, South Korean computer. They used a Hyundai 8088 or an 8086 computer because the benchmark speed is 4.43 megs, isn't it? Something like that. And even 10 megs computers sometimes were a struggle. Anyway, this computer does work alright. I did put the Dymo label on, or is it a brother label, saying which is socket 1 and which is socket 2, and we can pop that into the socket, dropping it on the way round. Not putting any pressure on because of the glue. So that plugs into there, and that plugs in through all those wonderful adapters into our serial port. I can't be bothered to screw up the thumb screws. Now we've got a mains adapter here which needs to be capable of 1 amp. So not 300 milliamps, needs to be regulated 1 amp, 12 volts. And that's exactly what we've got. It'd be better still if we got a socket spare. don't know what I'm going to unplug, and it's going to be a problem, but oh, is that a spare socket? Good. This button is a clone button. There's some procedure where you can, I don't know, I don't even remember on the training course, it's so long ago, but I think you can put the chip you want in 1, the chip you want to program in 2, and press the button and it just clones it without a computer. So we're lit up. I'll switch the computer on, which has been off for a long time, so it will no doubt ask me all kinds of stupid questions. So it thinks it's a colour screen, but it isn't a colour screen. So end, save changes and exit. Are you sure? Yeah. Now it'll do its times tables. Sorry about the washing machine in the background. This room comes off the kitchen, so it's a bit noisy like that. So change directory, SMP4001. I think it's just SMP4001. Set up programming parameters, it asks. So it's SMX4050N, was it SA? You see, already forgotten. NLA. Select EEPROM to program. We'll have it in 1. Read. And at the moment, that's what's in it. And if you look at that, it's all programmed with 4 meters. Good. Well, I don't need to do anything. That's it. It's already on, and channel 13, unlucky for some, is calling channel of 70.45. So you've got some other facilities here, and we've got the transmit timer disabled. These are some delayed transmit. Sometimes you've got to leave half a second for a system to activate, so things like that. Lockout when you've got business repeaters. I've got scan disabled, and so on. You can put these in the scan table, but you can actually do that later if you have a copy of the instruction book. So it's actually doesn't need anything doing. I wasn't expecting that. So channel 13, I think we'll remember that. So we'll get out of it. Oh well. And somehow we will, I'll just put CD ... There we go. We only use this computer for SMP4001, which is this, SMP4002, which is the systems version and has a lead which goes onto a 3-pin plug on the subboard, SMP4005, which is the hand portables like the SL70, and SMP6001, which does quite a few different sets of the newer types like the PM100 and PM160 and things like that. Well, newer by my standards, talking about sets in the early 2000s, because they're late 90s. So somehow I'll graph this video to the others. It is a different format, but I'm sure it will happen, and we will go over to the bench and go through the tuning of this radio. The first thing is a test point. There's the VCOs. The frequency trims are here. You've got coarse and fine. and this isn't going to have CTCSS, and so one of these is deviation. Then on the other side of the board, if you can take the lid off, you've got the receives. You need to do all the receives, and the detector is one of these. So then transmit power needs to be really, if you've got a 10 watt license, obviously it's 10 watts, but if you've got a higher license, then I would recommend setting it to 25 watts, and the power control is just peeping through there. So with the correct trimming tool, I'll pretend that this all is a trimming tool. You've actually got to get it through like that on an angle. So I think that's about it. But again, the service manuals come up for the PM150. So the VHF low band, to recap, is SMX4050, and NLA is the correct version. If you have the VHF one, it's SMX4150. If it's NH, it will not go on 2 meters. If it's NM, then it will go on 2 meters. The odd set, NH, is high band, you see, may go on 2 meters, but you'll be changing capacitors in the receiver. And then finally, the UHF version is SMX4450, and if you end up with the high band version, you're unlikely to be able to get it on 70 centimeters. The radios are 45 watt capable, but you'd be thrashing them at that, so we set them at 25, as I say. So with that, I can put the chip back in. That really surprised me. Good, so I'll get that over to the bench. I've got something on there at the moment, so that's going to have to clear off first, and then we'll come back to it. Right, so it's not CB, is it? But here we are on this bench with the PM150. I've had to plug it into our bigger power supply, which we don't normally have on here. We normally have a 2.5 amp power supply. I've had to bring the one and only, we've got an 18 amp, is it? So there we go. It's going to want to turn on at 13 surely. I seem to remember, I may be getting, I haven't got the instruction book with me. There is one, I think it's in my bedroom, believe it or not. You switch on pressing one of these buttons. No. No. Yes. Let's now turn it back on. And now it boots up on channel 13. So switching it on, going into program mode with P, manipulating which channel I wanted, and then pressing S, like program and store. So now it boots up on the calling channel, which is sensible. It's probably exactly what the customer doesn't want, but you know. Now we're normally doing CBs on here, so we normally would have the PL259. Now we need a BNC adapter. Now this radio is capable of 45 watts. Our test set only goes up to 30. So I need to make sure we're not going to... This customer's got a 10 watt license. We'll make sure it's set to 10. What have I plugged this into? Do you know what I've plugged it into? I've plugged it into the CB aerial. Let's try the test equipment instead. The mic's in better days. He doesn't know whether it's worth having it. Well, I'm sure he didn't pay £367 plus VAT for the radio, so it's well worth having another mic. So here goes. Picture in picture on. Transmit. Well, it helps if I turn it on. So it's doing about 18 watts. So I'll turn that down to 10. Deviation. Now I'm going to have to retune the test set. So it's going to be somewhere about there. Wallow. So he's got the deviation far too high on this. That's done from the other side, so we'll worry about that later. So let's see how the receive is. So again, we need to put this into a different mode, and I'll put the frequency counter up and then you can watch me tuning it in. It's 70.45. Test set's been on all day. Okay, put the cyanide meter on and we'll plug that into the extension speaker socket, just like we do on a CB. I'm just going to go back to transmit and we'll just see what frequency it's transmitting on. So that's near enough. I'll trim that later, but it's near enough as far as tuning the receiver is. Deaf as a post, folks. He's doing 4.6 microvolt, 4.4 microvolts for 12 decibel cyanide. 4.4 microvolts. So it looks to me like it's been programmed, the VCO locked, and nothing adjusted. That's probably why it's here. Okay, so as we would normally, I'm going to do the detector first. It does sound awful. So we'll go over to the oscilloscope. I can't quite remember which coil it is, and I'm not even sure I can be bothered to find the service manual. I think it's T10 on its own down there. Yeah. Absolutely miles out. What a silly position that was in. So turn the volume down. I'll take this bench light off like I usually do. So that's made all the difference for a start. Let's just see what the cyanide is now, because it may have improved it. It has. It's now still a ludicrous 3.5 microvolts. The 12 decibel cyanide, so it still needs a lot of attention. So we'll get that down to 4 dB like we would normally. Show that on the screen. We'll go through the
receiver. There's no improvement there. Of course, this set may be a wrong band set, which has been wrongly labelled. No improvement. Just go through these. It's that one, miles out. I was beginning to think I was going to have to live with it like that. So we're now at 1.1 microvolts. And it's still coming up. Now at 0.65 microvolts. Here we are. So it was the right band after all. Let's see where we are with the 12 dB. It's 0.95 microvolts. A final go with this. That's where it is. Anyway, that should be fine. Good. We'll put the bottom lid on then. And it actually says NLA on the board there, so you know it hasn't had the lid swap. That's a trick, you know, passing off a model when it isn't. So really we just need to look at the deviation, just check the squelch actually works. I'm not aligning it like I would a CV radio. Now deviation is which? Which is it? One of them is digital code squelch, one of them is CTCSS, and one of them is normal deviation, and one of them is squelch. Let's get that little oscillator out. At least I can put this back right at whatever I had just wrong. So put that back on the screen. Wallow. So I need to adjust that down considerably. So is it that one? It is. Wallow. Bring it back down a bit more. Wallow. Or is it 5 spacing on... is it 5 spacing or is it 12.5 spacing? Honestly can't remember. Let me look at the channels. So if the current frequency on 70.45, the next channel up is 70.45025. So it is 25 spaces. The deviation needs to be 5. So it was a bit over the top, but it was a bit nearer than I thought it was. Wallow. So I need to bring it up to 5. Wallow. That's now over the top. Wallow. That's 5. So that's that done. There we go. We are done. So no, not going to be any on the air tests with this because I haven't got an aerial in here. We have demonstrated this type of set before on 4 meters. So you're calling channel 70.45 in the UK. I say this radio, I have one of these and mine's set for 25 watts. I don't like to thrash it, but they are capable of 45. We'll just pop this on spot on frequency. No, it's not going to come down any further with that trimmer, so we'll go over to the other trimmer. There we go, I'll do nicely. So we have it, Maxon PM150, already programmed on 4 meters, but I went through the motions of doing that with you, and now doing 10 watts, which is the chap's license limit. And I think these have got a dimmer on them as well. Is it that button? Some of these have got a dimmer. Yeah, there it is. So we have it, Maxon PM150, SMX4050 NLA on 4 meters amateur band. Thanks for watching.